Hi friends, welcome back. After looking at the different types of reinforcement learning, different phases involved in reinforcement learning, now let us see some algorithms defined for reinforcement learning. Basically, we can divide the reinforcement learning algorithms into two types. One is model based, and the other one is what we call a model free. In the model based approaches, we learn a model of the environment, and this mathematical model, which is the copy of the environment, is used to predict the future states and the corresponding rewards. So we first work with the environment, try to understand the environment, and then uh, mathematical equivalent of the environment is created, which we call a mathematical model, or in general, a model. And this model is further used to predict the forthcoming states and the corresponding rewards. Whereas on the other side, the model free methods don't create any model for an environment, but they directly learn by interacting with the environment. So they just interact with the environment, and while interacting with the environment, that means interacting with the environment is nothing but taking some actions in some state of the environment, and we understand the reaction of the environment for that particular action, and this reaction may be a positive reward or a negative punishment, and this we try to add to our knowledge bank, and with time we keep learning. So that's a model free method. Then there can be tabular method or deep learning reinforcement learning method. In the tabular reinforcement learning method, it uses a table to store the Q values for each state action pair. What Q values are, we'll see in a short while. Whereas the deep reinforcement learning techniques use a neural network to approximate the Q function, whereas in the tabular method, we have a table which stores the Q value for every state action pair, whereas in the deep RL method, we make use of the neural network to approximate this Q value, and hence it enables large and complex state spaces to be very easily accommodated. But that is not easily possible when we talk of tabular method, because for every possible things should be put in the table, and that becomes an exhaustive table, and hence not feasible when we have a huge state space. So when it's a huge state space, neural network version is more preferred compared to the tabular one. Now, as we just looked at the beginning, we had two types of reinforcement learning. One we called it model based, and the other one we called model free. So let's look at each of these in little detail. model based. So here the agent learns a model of an environment. So we mean model by a mathematical model. So a mathematical copy of the environment is first created, and the creation of this is done through the learning of the agent. And once this model is ready, and this model is given with the current state of the environment and the input, and the model will predict what could be the consequences of any action at any given state. So that's model-based reinforcement learning. So it does has advantages like when we are working on when we talk about sample efficiency, so we can learn faster with very few interactions with the environment because here we are simulating the experiences through the mathematical model, and because we are not taking any action immediately. Before taking action, we just look at what could be the consequence and all that. So there is planning possible before taking action when we talk about a model-based reinforcement learning. So at any given state, let's just verify which of the actions will do what, and then finally decide which action is the best one, and then really take the action in the real sense. So all other things are done under simulation. So we can very well plan during the simulation, and once we are through, then take real time action. Yes, nothing comes free. There are disadvantages for this type of learning. So first one is about model accuracy because the performance of the agent depends only on the accuracy of the learned model, and the learning is done only through whatever inputs it has seen, whatever environment states it has come across, and in those, whatever actions it has taken, only that information it is having, and anything out of that is difficult to imagine, and because of that, we can't guarantee about the accuracy of the model. The next issue is about the computational cost. Yes, learning is one thing, and then using this model. So for creating the model, we do have to spend resources and time, and hence it will be computationally expensive. And once we have created a model, and if we find that something are not up to the mark or something are not very satisfactory, then we need to modify or tune it. So, and in case of model-based reinforcement learning, once the model is ready, tuning or modifying is very difficult. It is too complex task, and hence that will be an advantage, disadvantage of model-based reinforcement learning. Then model-free reinforcement learning. Here, we don't create any mathematical model for the environment. The agent directly starts interacting with the environment and there is nothing like a model or something. It just sees which state the environment is and takes some action. And because of that action, there will be some uh, reward or punishment, and it just puts that in its knowledge bank and continues. So here, the agent is learning through trial and error, and it creates a policy, and this policy gets adjusted, or it just keeps fine tuning the policy based on the rewards it is receiving. So at any time, we are in say state S1, and action A1 was taken, and we got some reward or punishment. In future, on the way, and if the system or the environment gets back to the same state as one, and now if we take some other action, say A2, and if that action is better, it gets a better reward compared to the previous action A1 in that same state, then now we modify our policy and say that if we are at state S1, instead of taking action A1, it is better to take action A2 because now A2 has given a better result. So we update our policy, and this is a routine at every step. We just keep doing. And here, one option is make use of the best solution, that is exploitation, or try something new, which may get us a better result, that is exploration. So, exploration, exploitation is to be used in proper order so that it can get us a best possible results. The advantages of this type of reinforcement learning, it's simple, easier to implement, tune, because we don't have to create any model, and therefore we just as we keep moving, we just keep learning. So it can be more robust compared to the model based because it is very easy to handle any complex and dynamic environments because the environment need not be static all the time. It keeps changing. And when the environment or the situation changes, then the whole model has to be re-updated, and that's going to be too costly affair. But in this case, it just keeps updating, and there is nothing like a model. Therefore, it's more robust compared to the model-based one. Yeah, again, nothing comes freely, so they do have some disadvantages like sample inefficiency. Now, in this case, we do require a large number of interactions because we don't have any simulation possible here. Therefore, we have to have large number of interactions so that uh, our system can have a better effective policy learned. And there will be again have a problem of balancing exploration against exploitation. So it is difficult to decide how much exploration we should have and how much exploitation we should have so that the overall situation is at its best. Yeah, that's a summarization between model based and model free. Model, the model based thing learns a model of the environment, does not require any such model in case of model free. Learning, it is learned through the simulations as well as real-time interactions in case of model-based, whereas in case of model-free, learning is only on the real interactions. There is nothing simulation possible here. Planning is possible with model based because we are working with a model and model is being created, and once a model is created we can just simulate the situations without actually taking the actions. We just imagine what if we take this action, what if we take that action, and all that. And once we understand the various results or rewards of different actions at any given state, then we can decide which is the best one. So we can make a better plan in case of model based, but in model free, it's purely trial and error. We can't make a proper plan in advance that the next action will definitely get some reward or punishment, not guaranteed because everything is on trial and basis, and we don't have any mathematical model for the environment, and hence there is no prediction possible through simulation. In case of sample efficiency, it is more sample efficient in case of model based, but model free requires a lot number of samples to understand the actual nature of the environment. Complexity wise, if you look at it, model based is more complex to implement, and on the other side, it is simpler to implement in case of model free. The environment, it's best suited for predictable environment. So if you have environment that is more predictable, then model based systems are better. But if it is too complex and too dynamic case of environment, then it's always better to use a model free reinforcement learning system. Yeah, pictorially, if you like to summarize this, so we have an experience, and this experience is used in the building the model, and we do have a model, and this model will help us in planning. So when you are working on model-based approach, then the experience are fed to the model, and the model will get us the plan, and through that we can get a value function, and this value function can create as a policy. So this why a well model if we go, then it is a model-based approach. And in case of model-free approach, the experience directly produces the value function, and these value functions can be accumulated, and a policy can be created. On the other way of presentation, yes, we have experience, we learn, and we create knowledge. In case of model-based reinforcement learning, a knowledge is created, and this knowledge is used in uh, planning, and through planning, we can have a behavior of the system defined. That's model based, whereas in model free version, the experience is used for learning, and through learning, every experience gets a value, and this value is useful in selecting the action. So here in model based, knowledge is created, a model is created, and this model is used for planning, and through the planning, behavior is decided. Whereas in the model free environment, experience learned will become a value, and this value will decide what action to be taken, and that shows the behavior of our actor. So, take an example. So, in this case, in the case of maze, yeah, the problem is almost static version. There is somewhere we begin and there is somewhere we end, and we need to find the path from the start to end. And once a problem is defined, the whole environment remains the same, and each time we are going to get the same route and all that. So when we are talking of this type of situation, then we can go for a model-based type of reinforcement learning, because if we can create a model for this particular environment, then every time we can make use of these actions and then get the work done. Because the number of possibilities and all are limited in number when you look at this particular problem. On the other hand, if we look at the game like chess, so if you can see some green marks are shown here, and at any time, maybe at this instant, a player with a white is about to make the next move. Then the player is trying to see what all are possible. So there are so many possibilities that can be taken up, and the volume of possibilities, if you look at any given step, is so huge that if you just keep accumulating, then it's going to be your almost infinite possibilities. Therefore, we just can't create any possibilities as a whole as we could have done earlier. Therefore, it is not possible to create a model like thing and then work on that. So when it is just like game, it is better to work on a model-free environment than a model-based environment. So the various algorithms we have, it can be value based, it can be policy based, or it can be actor critic. So value based is one where the Q values at any given state for any given action pair is to estimate the future rewards. Here we learn to estimate the future rewards at any given state action pair. Whereas the policy based, they directly optimize the policy, and the actor critic is the combination of the value based and policy based. So more details about these terms. Yes, of course, look a little confusing. More details to follow in the coming sessions. So keep watching. Thank you.